Alright, so in this video we're going to look at the different types of synovial joints. There are actually 6 different types of synovial joints, and they're categorized based on the shape of the articular surface, like whether it's a plane surface, whether it's condylar or ball and socket or saddle shaped, and as well as the type of movement that joint is capable of. So the first one we'll talk about is the plane joint. We've discussed this earlier as one of the non-axial types of movement, because it's more of just a slipping motion across flat articular surfaces, like in your carpals, your tarsals, as well as the articular surfaces of your vertebrae. And so because of the slipping surface, we can think of this as being a plane, where they basically just can slide across each other. So these plane joints are really good at sliding movements, or gliding movements rather. So if you move your wrist back and forth, the carpals are going to slide and glide against each other, but in a non-axial way. Now the hinge joint is actually shaped like a hinge. And it's where you basically have a cylinder within a trough. And so this would be the cylinder shape here of the trochlea of your humerus. This would be the trough, which is the trochlear notch of your ulna. And together they make this elbow joint. Now if you think about how the elbow joint can move, it can rock back and forth within one plane. So we think about this as being uniaxial, because it can move along one plane. And that plane would basically be the sagittal plane, because you can flex and extend along that plane. Now the interphalangeal joints, or between your fingers, are also considered a hinge joint because they have this particular hinge-like structure. Now a pivot joint is pretty fascinating. One example of this is where you find the ulna and radius articulate at the proximal end, where the head of the radius can actually rotate around the ulna. And what's pretty cool then is that the head of the radius is actually encased in this little ligament, and what's neat then is this sleeve of bone surrounds the radius, and basically this axle moves. Now in this example it's not a bone, this is a ligament, but an example of where you'd find a bone here would be like the atlas and axis, where they articulate. Now this rotational movement is going to move in one axis as well, and this axis is going to be just along the longitudinal axis of this particular bone. So we think about this is going to aid in the rotational movements like supination and pronation. So as your forearms supinate and pronate, the head of the radius can rotate within the sleeve in order to move your whole forearm. Now an example of a condylar joint is going to be like the metacarpophalangeal joints, like where the metacarpals meet the phalanges. And it's called a condylar joint because you have an oval articular surface that one's concave and one's convex, and they kind of fit into each other. Now this is considered biaxial because you can move in many different directions here, or multiple directions rather. And this condyle is going to be fairly stable due to the shape of these bones. So other examples of where you find condylar joints would be like your wrist joint or the metacarpophalangeal, or basically these are the knuckle joints. Now an example of a saddle joint, where it actually looks like someone sitting in a saddle here, is we have convex and concave surfaces that kind of interlock against each other. An example of where you'd find this would be the carpometacarpal joint of your thumb. And so this allows for your thumb to move in a biaxial motion, right, front, back, and side to side. And so it allows for adduction and abduction, as well as flexion and extension of the thumb at the level of the carpals here. So that's pretty neat. Now, the ball and socket is basically what it sounds like. You have a ball, and it sits in a socket. And one example of this is going to be the shoulder joint, or also the glenohumeral joint, as well as your hip joint. And in both these cases, you have a ball-shaped head of either the humerus or the femur that sits in a cup-shaped or a socket-shaped other bone, whether it's your scapula or your pelvis. Now, this is going to allow for the most movement. It's actually multi-axial, so it's the most movable joint because you can move along all 3 different planes. It can rotate, it can abduct and adduct, and flex and extend. So this is going to be capable of things like circumduction, which use a mixture of all 3 of these types of motions. Now, if this is a multi-axial type of joint, this also means that this joint is one of the least stable. And that fits our rule in terms of the trade-off between mobility and stability, where highly mobile joints are often the least stable. In fact, your shoulder joint is one of the most commonly dislocated joints in the body because of the fact that it's so movable, and there's really not a whole lot holding this on other than some muscles and supporting ligaments.